Okay, so Xander has a question about the quiz. So let's look at that. So which one, Xander?
We do number 2 and this one. No.
Which one am I doing?
Number 2.
Number 2? So this one? Oh, that's one.
Yeah, that's
Two.
one.
Oh, sorry, yeah. I'm looking at the second problem, that's one two. Okay, so problem 2. All right, so I want to find the inverse of this. Okay, so what's the first thing I always do no matter what? We have inverse problems in other sections. It doesn't matter. If you're finding the inverse, what is the first thing you want to do? Switch the x and y. So this is y. So I'm going to have x equals -2 y. Okay. Now, ultimately, we need to end up with g inverse. That's going to be our answer. That's y. So we got to get that guy by itself. Okay, so what do we need to do to make that happen? Add 2. And then divide by -2. And you can either do that all in one chunk or you can separate it. If you separate it, it would be -1/2 x minus 1. Or you could leave it as one big fraction, x plus 2 over -2, it doesn't matter. Okay? Now we have a problem because we've done all of the basic arithmetic, moving things around side to side. Now we have to get rid of that logarithm because we got to get that. Okay? So how do we remove a logarithm? We log roll it. Yep, we log roll it. So 6 to the -1/2 x minus 1 power will equal y plus 4. And then I'll just subtract my 4. So my inverse is 6 to the -1/2 x minus 1 minus 4. Okay, Xander?
Yeah, that makes sense.
All right, what else? Any question anywhere? I don't care.
Can you do number 7 on the quiz?
Quiz, number 7. So again, this happens to be a logarithmic inequality, but we need to solve all kinds of inequalities. And in this course, a point of emphasis is on sign charts. So I know at some point, I'm going to be drawing a number line and determining where things are positive and negative, right? Now, this is a logarithm problem. Logarithms have issues with domain, period. They just do. So, at some point, it can be now, it can be at the end of the problem, it can be any time. You have to take note that this must be positive. So whatever else goes on in this mess, x has to be greater than 1/3. No answer can happen unless it's greater than 1/3. This one says x has to be bigger than 0. Well, that's a little redundant because if you're going to be bigger than 1/3, you're automatically bigger than 0. But I'm going to go ahead and write both of them down to remind myself that anytime I have a logarithm, I have to think about that. Okay, now I'm going to actually solve the problem. So the first thing we probably ought to do is put this together as a division. Now, somebody had an interesting strategy. I'm going to talk about it in a minute. I'm going to go ahead and do this. I'm going to talk about an idea somebody else had that's kind of cool. But here we are, right? Now, we can draw the logs from both sides. So 3x minus 1 over x is less than 2. Now, somebody, several of you, multiplied both sides by x. Can we do that in an inequality? No. So we're gonna have to get our 0. Remember, inequalities are all about sign charts, all about positive and negative. So you wanna have a 0 there. Now we can build a single fraction. That looks like that. Did I do that right? So then I can draw my number line. Am I on, no, that's separate. I'm gonna do that in a minute. But this right here, 0 and 1. I want that to be negative. So I'm gonna start checking some numbers. Let's see, a -1 would give me a negative over a negative. That doesn't work. A 1/2 would give me a negative over a positive. That works. And a 2 gives me positive over positive. That doesn't work. So the answer to this part of the problem right here, the answer to this part of the problem is that little section right there. But we gotta throw these in there also. So if we have to be bigger than a third, and again, I've already taken care of that part, bigger than 0. I'll go ahead and draw it in there, but we have to be pink and red and black. So what part of that is pink and red and black? 1/3 to 1. Now, some of you have, oh, I don't wanna hear it. I don't wanna hear it. If your work isn't legit, your answer doesn't matter. Okay? So before you say anything, make sure that work's legit. Because if it at any point involves multiple, if on your paper you have this, you are not legit. So I don't want to talk to you about it. If you feel that your work is legit, I'm happy to talk to you. Not right now, but I'm happy to talk to you about it. Okay? On free response questions, guys, the answer is not the important, I mean, the answer is important, of course, but the problem is worth 18 points, okay? The answer might be worth 2 of those. Where are the other 16 points coming from? The work. You have to have work that makes sense to whoever is reading your paper. In this case, it's me. With the AP exam, it'll be some stranger. Whoever's reading your paper has to understand what you're doing, and it has to be mathematically sound. You can't luck into the answer. You can't guess the answer. On multiple choice, you can. On multiple choice, absolutely. But not on the free response. Okay, now I want to show you what somebody else did with the problem that I thought was cool. Somebody, it actually made the problem easier. Somebody said, I'm going to rearrange this. Now, is that mathematically sound? Are you allowed to do that? Add and subtract things from side to side? Yes. Then when we put these together, see? So now we have this inequality, and are we allowed to multiply by 2? Yeah, no problem timesing by 2. So that eliminates the need for this black part of the sign chart. Right? Yeah, it's pretty slick. Somebody did that, yeah. You are always allowed to rearrange terms if the equation you think might work better in another order. Okay, who else? Julia? Okay, listen, I couldn't hear you. What do you wanna do?
Number 1 and 2.5.
So number 1 on 2.5, we're on the review now. On the review. And we're going to end up with an equation, hopefully, that looks like this. So in other words, it's going to be a vertical translation of an exponential function. And I've got this chart over here with points in it. Okay, now, the first thing I would suggest you do is, you know you're shooting for exponential, right? So what should be happening over here? If this is exponential, what should I observe when I do my differences over here? They should be proportional. So let's see what they are. Let's see, this one's 6, this one's 12, this one's 24, and this one's 48. Now that is exactly what I would expect to have happen. But what does that tell me? That tells me that my B value is, what am I multiplying by? 2. So my B value is 2. So by looking at the differences, I can tell that my B value is 2. So y equals A times 2 to the x plus c. Now, we do this a lot. At this point, when I gotta build an equation, can I come over here and start plugging in points? So if I plug in 7, 0, 7, I get an equation that says 7 equals A plus C, right? And then 13 equals A times 2 to the first plus C. So 13 equals 2A plus C. And then, you know what to do, we just, looks like A is 6. And if A is 6, then C would have to be 1. So my equation, Julia, is f of x equals 6 times 2 to the x plus 1. And after I write my equation, it's always a good idea to go back and just double check. So if I put in 3, do I indeed get 49 if I put 3 in there? Yeah. Okay, Julia, that makes sense? Good question, okay. Emily?
Can you do 1B on the quiz?
1B on the quiz. Okay, this is an equation. Kind of like the one we just did, it's an equals though. So we're gonna go ahead and put these together, Emily. This guy becomes an exponent, right? So I'm gonna have the log base 4 of x minus the log base 4 of 9. And then I'm gonna go ahead and put those logarithms together again. It's gonna go together as a division. And then I can just solve the equation. So let's see, x equals 9x plus 63, negative 8x equals 63, negative 63/8. But this is a logarithm problem, and what do I always have to pay attention to? Domain, domain, domain. So in the beginning, what does this tell me? X has to be bigger than 0. What does this tell me? X has to be bigger than -7. If you were drawing it on a number line, that would be green, that would be blue, and this little dot would be pink. And if the pink dot is not in the blue and the green, then it can't be an answer. Is this bigger than 0? No solution. Okay. Every time you see a logarithm, have a buzzer go off in your head. Domain, gotta check. Every time we have a log. All right, what else? Who else has found something?
Can you do number 27 on the 2.13 homework?
27. On the 2.13. All right, so ln x squared plus 5 has to be greater than ln 7x minus 7. So there's no combining to do here. So I'll just, x squared plus 5 is greater than 7x minus 7. So x squared minus 7x plus 12 greater than 0. Okay, it's an inequality. I know there's going to be a sign chart involved. What should I probably do with this guy? Factor that. So here's my 3, here's my 4. Let's see, 0 gives me negative times negative, that doesn't work. 3.5 gives me negative times positive, that works. Oh no, I want positive. Yeah, 0 does work, thanks, yeah, 0 does work. This does not work, I want positive this time. Positive. And then 5 will work. So the answer to the actual X part of the problem, I guess, whatever this part of the problem, the answer is all that. But again, it's a logarithm. So I gotta go back. This one I don't need to worry about because it's always going to be positive. But this tells me X has to be bigger than 1. So on top of what I've already solved, I have to be bigger than 1. So what is red and black? Everything from 1 to 3 is red and black. And then everything from 4 on is red and black. Okay? Anna?
Oh, and then wide on 2.8. Can you do number 2?
2.8. Number 2. How do we prove that things are inverses? There's a very specific way to do that. How do we do it? If they're inverses,
Put the other one in there.
you build a composition. So f of g of x has to equal x, and g of f of x has to equal x. This is how you prove that f and g are inverses. You build them in composition with each other. Okay? So, what are my functions again? My functions are, here's f, and here is g. Okay, so if I'm doing this one, I'm going to plug 1 minus 2x over x into my f function. So g is going into f. So 1 over 1 minus 2x over x plus 2. Now, to clean that up, you can do it, there's options always. I like to just multiply everything by x, because that will get rid of my fraction right here. So I'll have x over 1 minus 2x plus 2x. Oh gosh, what is that? That's x over 1, which is x, which is exactly what I had to do. Now I'm going to turn around and do exactly the same thing in the other way, the other order. So I'm going to find g of f of x. So I am plugging my f function is going into my g function. So 1 minus 2 times 1 over x plus 2 over x. So I'm putting my f function right in here. Tanner?
Now put the 1 over x plus 2 on the denominator too.
Oh, yeah, you do, thank you. Put it in for all the x's, absolutely you do, yes. Thank you, absolutely, all the x's. All right. Now I think I have it right, let me double check. I'm putting this in here and here. Yeah. All right, now, again, you can clean that up any way you want. I'm gonna multiply everything by x plus 2, because that'll get rid of these fractions. So I'll be left with x plus 2 minus 2 over 1. How do we prove things are inverses? What do we to each other, basically? What do we to each other? I end up with x. What here?
I'm just trying to process. Wait, so that -2, the 1 minus 2, would that also be on top of 1, technically?
It's up here.
Yeah.
Yeah. Okay, what else? What else do we have? From anything, we've done homework, quiz, review sheet.
We do,
Julia?
2.4, number 1.
2.4, number 1. Rewrite this with no horizontal translation. Okay, so these problems are going to be easier if you understand what we mean by a horizontal translation. When you look at this problem, do you recognize it's an exponential function that's been shifted 2 units to the right? That's a horizontal translation, sideways. So your job is to make that go away. You want a plain X, right? Well, we can do that. What does this mean? It means 3 to the X and 3 to the -2nd, because when exponents are added, it means the numbers have been multiplied. When you put this together, you would add those exponents, right? So it's just undoing that. Well, what's 3 to the -2nd? 1 9. So we have 2 9ths times 3 to the x. Now, is that gonna be the same picture as that? Yes, only now it's written without the translation. What's this?
That's
A vertical dilation. That's a vertical dilation. The original problem had a vertical dilation and a horizontal translation. All right, Xander, you were gonna say something?
yeah, can we do, 2.9, number 3 to 9?
best that they can. Don't make this hard. Don't make it hard. The log base 6 to 12 can always be written as the log of 12 over the log of 6, right? In fact, if I had to find a value for that, this is what I would type on my calculator. Now, does this have to be log 10, base 10? It could be any log I wanted, including base 8. Any base I want.
So natural would just be log 12 over log 6? Or would it be
This is natural.
that's natural up there, maybe that's what
Oh, folks, we need to know that. Natural logs are ln, log base E. Common logs are log base 10. It's kind of fundamental. Let's make sure we got that. Okay. All right. Okay, what else do we have? Where's your land? Yeah. Why are you wearing your little sweatshirt today? Oh, wait, it's Friday. Good.
Ooh, wolf pack.
Did you say wolf pack?
Yeah, you see the sweatshirt right here?
I don't care. Is that one of the football, like, you all have nicknames?
Sure is.
Okay, awesome. All right, what else? Let's go, what else? Come on, you guys gotta do some studying on your own. What did you come up with for question marks? Josie? 1.2, number 4. 1.2, number 4. From the instantaneous rate of change, what's g of x? G of x is negative x squared plus 4x minus 2. And we want to find the instantaneous rate of change at x equals 2. Now, I want you to think about this for a second. First of all, there is a calculus way to do this that's like this. But we don't have that skill, so we are going to do this from a more logical, a little more tedious way. Would you agree that you could find the average rate of change, let's say on the interval from 1.9 to 2.1? Could you do that? Yep. Could you also, so you can do that, could you also find the average rate of change on the interval from 1.99 to 2.01? In other words, you see what I'm doing? I want to find it at 2. But to do my average rate of change, I actually need 2 numbers, f of b minus f of a. So what I'm doing is I'm squeezing in on both sides of 2. So I could do the average rate of change 1.999, 2.001. And the closer I squeeze in on 2, the closer my average rate of change will be the actual rate of change at that point. Does that make sense to you? So I would say, let's just do this. Let's find this right here. Okay? So I'm just gonna do that last one. I could do all of them, but there's really no point. I'm probably gonna do this one right here. So what would that look like? The average rate of change of that function on this interval would be g of 2.001 minus g of 1.999 over 2.001 minus 1.999. Would everybody agree with that? Every time we do a rate of change problem, we're going to set up that formula. Okay, now we'll get our calculators out. And we're going to find find G of 2.001, which means plug in 2.001. So negative 2.001 plus 4 times 2.001. Okay, so I got 1.999999. I hope I typed that in right. Anybody else get that? And then I'm going to do the other one, so negative 1.99 squared plus 4 times 0.99 minus, oh my gosh. Now, this, I just made up this problem, but this one is going to turn out to be 0. The average rate of change at that point is 0. Now, that isn't gonna happen, it just, yeah, I should have made that a 3, then it wouldn't happen, but they happen. This is how you would do the problem. Normally, you're gonna get a number up here that's not 0, and that would be your approximate instantaneous rate of change. Look at all those decimal places I took, so when I round it off to 3, it'll be instantaneous rate of change. Okay, does that make sense to everybody? Josie, does that make sense? Okay. All right, who else has a question about something? Oh, is it an emergency? I mean, if it's an emergency, go.
Like, no, but I have to go.
The deal we went through on Tuesday, you understand that if you leave class and you go to the bathroom, and the sheet comes on and says, we're in lockdown, the doors go shut, and you're kind of on your own. So before you, I mean, I don't want you to pee in your pants, but decision you have to make. Leave it to your wife, or be uncomfortable, right? Okay, what else? Who else has a question? Drew?
Can we do number 4, 111 on the review?
1.11. Number 4. What is the third term? What is the third term of 2x minus 8, or 3, 2x minus 3 to the 8th? All right, who remembers anything about this?
Oh, Pascal.
Okay, we know that when we multiply this thing out, and luckily we don't have to, we only want one of the terms, but every term of this expansion, we FOILed, every term would have a coefficient, a power of 2x, and a power of -3. Okay? Just like when you multiply x minus y squared, every term has a coefficient, a power of x, and a power of y. That's what we're doing right here, okay? Now, we can use Pascal's triangle to help us find the coefficient. We would need to go to the 8th row of the triangle. So remember, the triangle is built, there are 1 and a 1, and then we add these together. Okay, everybody remember this?
First term's technically double 1.
Yeah.
First row, yeah, this is the 0th row. Because if you raise something to the 0 power, you just get 1. Now, here's the good news, I'm not gonna write the whole thing out, because in the 8th row, the number I want is the 3rd one, right?
Yeah.
So I don't need to write out the whole thing, I just need this beginning part right here. So that coefficient is a 28. Okay? Now, I need to figure out what my powers are. So think about when you FOIL something together, like even look at this little one. The first term has an exponent of 2. So if it were to the 3rd power, the first term would have an exponent of 3. So the exponent on my 2x in the first term would be 8. And then here it would be 7. And here it is 6. So the exponent on my x part, my first piece of my binomial, is 6. Which means the exponent on my 3 is 2, because they gotta add up to 8. Okay? And then I just have to simplify it. So keep in mind, this is multiplication. So it's 28 times 64 times 9. So it's 16,128. Well, no, that's not equals, but the third term would be x to the 6th. Oh, that's it. Okay? Everybody got that? All right, let's do one more. One more.
Anybody?
Can you, on the extra, on like the extras page, can you do number 4? It's talking about like 61 crickets.
Okay. So there are 61 crickets after 2 hours. So I feel like I have a T-chart here, but I don't really have a chart. If X is 2, I've got 61. And if X is 5, I have 275. Now that is only 2 points. So there is no way I can tell what I'm supposed to do with this unless they tell me. And luckily they do. Use an exponential model, okay, to determine the number of crickets after 10 hours. Okay? Right, and I have no directions here, so I could do this with regression on my calculator. I could also remember that an exponential is this model, so I could set up 2 equations. What would those equations be? 61 equals a times b squared, and 275 equals a times b to the 5th. So 61 over b squared equals 275 over b to the 5th. If I solve both equations for a, you with me? So then 61 b to the 5th equals 275 b squared. So it looks like b cubed is 275 over 61. When we did geometric sequences, you guys often said this geometric. So you did 275 over 61, and then over here, that was 3 multiplications, so you said r cubed, and it ended up, it's exactly the same. So then we can cube root that, and that's my b. So then I can come back up here and and plug that in and figure out what my A is, okay? So my A would be 61 divided by the cube root of 275 divided by 61 squared. So my B, A, that was my A. My A turned out to be 22.353 basically. And my B is that number, which decimally, I can figure out what that is. 1.65. So Y equals 22.353 times 1.652 to the X. Now, if we did an exponential regression, stat, and all that, hopefully that is the same equation that we would come up with. Hey, Drew, you're nodding. Did you do it with a regression or you just, no, that's what's going to happen. Yeah. Okay, so what do we need to do for Monday? Well, you need to start practicing some problems and coming with things from homeworks, from whatever, worksheets, whatever. You need to start coming with